Let's identify types of functions from a word problem. I know we all love word problems. Let's do it. Linear functions. Linear functions are a type of function that have a constant rate of change. And that constant rate of change is found by either adding or subtracting, because technically they're the same. Whereas an exponential function is shown by a proportional rate of change that is found by a constant rate of multiplying or dividing. So if you can look at a few terms in a row and say, hey, I'm either adding or subtracting, or I'm multiplying, dividing, that will let you know whether or not you're a linear or an exponential model. So for word problems, we all know that word problems can be tricky. They offer some information, some that may or may not be useful. So the key, if you're trying to differentiate between a linear and an exponential model, it could be helpful to try to find consecutive terms. Use the data given to write some terms in order and then do an analysis. Do I add or subtract to get those, or am I multiplying and dividing? Because if you can answer that question, that will tell you, are you linear or are you exponential? So let's look at a couple situations, and for each one, let's describe it as linear or exponential. A new gardener, this could be me because I am gardening right now. A new gardener checks all the tomato plants and notices 3 tomatoes. I did this just earlier today. It's very exciting. The next day, there are 12 tomatoes, and on the third day, there were 21. I mean, if that's not exciting for you, I don't know what's going to get you excited, but tomatoes are it for me. All right, so let's look at this. The first time there are 3, then we have 12, then we have 21. This is all I know. So when we're looking at this and we're comparing from 3 to 12, we have 2 options, right? We're adding 9 or we're multiplying by 4. Either one of these could be our pattern. From 12 to 21, I'm either adding 9 or multiplying by something that's ugly, but it's not 4. So I know that one doesn't work, but I do have a constant plus 9. So this is representing a linear function with a constant change of plus 9. Situation 2. In an effort to save money, a new college graduate puts 1 penny in a jar the day after graduation and doubles the amount put into the jar every day. You would not believe how much money you will have very quickly if you do this. It seems so simple because it's just 1 cent on day 1. And if you double the amount you put in every day, that means on day 2, I would put in 2. On day 3, I would double that and put in 4. Sorry about that little random line. On the next day, I would put in 8, and then I would put in 16, and then 32, and 64, and all of a sudden, I'm up to $1.28. You can see how quickly this gets real big. What am I doing here? Well, to double, that just simply means multiply by 2. So every time, I'm multiplying by 2. Therefore, don't know what that was. Got excited is what happened. Therefore, this is an exponential function with a proportional rate of change of times 2. Sometimes with exponentials, you also can look at 2 consecutive and put 1 on top of the previous. So like 128 on top of 64, you could put 64 on top of 32 and look at the ratios. If you do that, the ratio for all of these is also 2, because the ratio tells you what you're multiplying by. And that is playing with some word problems.